Hi everyone, welcome back. In this video, we're going to talk about fundamental counting principles, and this will serve as the foundational concepts to combinatorics in mathematics. So let's first have a look at the following example to see what is the fundamental counting principle and how can we apply it to real problems. So the example says, at brunch, you can build your own breakfast using the following choices. You can choose either sausage or bacon, and you have these 4 different options of eggs and these 6 different options of toast that you can choose from. And how many possible breakfast orders are possible? So in order to solve this problem, we're going to use multiplication principle. So this is when we have multiple steps of actions that we need to perform, and for each step we have a couple or more options that we can choose to do otherwise. So the first step in this particular case, we're going to choose whether we're going to eat sausage or bacon. Step 2, we're going to deal with the eggs. And last step, we're going to deal with the toast. So let's say, for instance, we choose sausage for our brunch. We can choose 4 different types of eggs. Just recall we have scrambled, poached, boiled, or fried, and I will use SPBF to represent the different options. And for toast, we still have 6 different options, and I'm going to just number them as 1, 2, 1, 2, 3, 4, 5, and 6. So this would be our 3 steps. So let's say, for instance, we choose sausage for our first step. We can go with 4 different types of eggs for our second step. And for each of those 4 options of eggs, we have 6 different toast options that we can choose from. So essentially, we can notice that for each option in step 1, which there are 2, we have 4 different options to correspond to, in step 2 to correspond to that particular choice in step 1. And for each certain option in step 2, we will have 6 different options that we can carry out after step 2 in step 3. So we will see that it is actually a multiplication. Because if we just focus on the first 2 steps, we can see we can go with sausage and scrambled, sausage and poached, sausage and boiled, sausage and fried. These are the 4 different options that we can choose when we select sausage for our step 1, and we can go with bacon as bacon P, bacon B, and bacon F. So these are the 4 options that we can choose if we select bacon as our food in step 1. So we can see that for each of the 2 available options in step 1, we can choose either 4 of the different types of eggs in step 2. Therefore, we have 2 times 4, which is 8 different options. And for each of those 8 options, for their third course, they can do either one of the 8 varieties of toasts in step 3. Therefore, we would have 8 times 6, which gives us 48. So that is how we obtain the total possible numbers of breakfast orders that are possible in this case. So this would be a interesting real-life demonstration of multiplication principle, which is one of the fundamental counting principles. And in a sense, the fundamental counting principle states that the total number of ways that a task can be performed is the product of the number of options for each individual choice that must be made. So let's look at another example right here. So example number 2 says, how many distinct arrangements are possible for the letters in the word English? So we will see that we have 1, 2, 3, 4, 5, 6, 7. We have 7 letters that are available in our toolkit. And we want to arrange these 7 letters to see how many different arrangements are out there. So we essentially will fill 7 empty slots with these 7 letters. So in the first slot, we would have 7 different options. We can choose either one of these 7 letters in English, either E, N, G, L, I, S, H. And in the second slot, since we have already used up 1 letter among these 7 letters, we would only have 6 letters left that are available for us to choose from. And in the third slot, since we already have used up 2 letters in these 7 letters, so we would have 7 minus 2, which is 5 letters that are available. And so on, so forth, that we should recognize that this is a descending number sequence. It's 7, 6, 5, 4, 3, 2, 1. And based on multiplication principle, that each letter, each slot is filled after the previous action being performed, which means that we need to fill the slot after we fill the slots before that. So we would actually use multiplication for all of these. And if we have something like this, if we have a descending number sequence with multiplication performed in between all of them, we would actually say it is 7 factorial, which is a exclamation mark. So this represents 7 times 6 times 5 and times all the way to 1. So this is how we would be able to calculate the distinct arrangements of the letters in the word English. So these are the 2 interesting examples that could be used to demonstrate how counting principles or fundamental counting principles, can be applied to real problem solving. I hope this video was helpful, and thank you for watching.